Hi everyone, welcome to the video lesson for Monday, March 1st and Tuesday, March 2nd. Today in class we learned how to convert between moles of one substance into moles of another substance using balanced chemical equations. But before we started all of that, we had a warm-up and then we moved on to part 4 of our Unit 6 notes. There were no new homework assignments assigned tonight. Just a reminder that if you've not yet taken your first attempt on the conversion checkpoint, you need to get that done. The second attempt gets unlocked Tuesday afternoon. Remember, we want to encourage you guys to come in and see us during our student support periods. We're more than happy to go over your wrong answers and show you the solutions. Now, there will be no points awarded for this, but I have uploaded some extra practice to the module. So if you feel like you're kind of shaky, if you're not sure if you really understand what's going on, I highly encourage you to try some of those old worksheets. Today's warm-up was a fun one. So I had you imagine that you were having a grilled cheese party for 10 people. Now we can all agree that grilled cheese sandwiches require 2 slices of bread and 1 slice of cheese. So if you're having a party of 10 people, how many slices of bread are you going to need to make everyone a grilled cheese sandwich? How many slices of cheese do you need? Well, that's a pretty simple problem. Most people have gotten this right so far. You're going to need 20 slices of bread and 10 slices of cheese. Now, that's a pretty simple math problem to do. 2 slices of bread times 10 sandwiches gives you 20 slices of bread. 10 sandwiches times 1 slice of cheese gives you 10 slices of cheese. I wonder, though, if any of you guys thought to use a factor label grid. I know that seems like extra work, but we're about to do a lot of problems that kind of boil down to this, pretty much boil down to using recipes, but we're using much more confusing things like moles and grams. And using the factor label grid will really help you. And so that's why it's good to practice using factor label on things that are really simple, like what we're going to do later on in class today, is a great way to practice using factor label. Because if you do the math and you come out with, you need 5 slices of bread to make 10 grilled cheeses, that's a pretty good indication that something is kind of off. So that's why I like using these really simple questions at the beginning for your warm-up to help you practice using the factor label method. And then, if you look in your pantry and you only have 14 slices of bread, is your party ruined? So again, I can use factor label. 14 slices of bread times 1 grilled cheese over 2 slices of bread shows me I can only make 7 sandwiches. So, in the classical sense of having 1 grilled cheese per person, this party might be ruined. However, I do like some of your guys' solutions for how to save the party. Very inventive. That was a joy to read. Here in our module for the 5th week of quarter 3, there's a link to make a copy of your Unit 6 notes part 4. So, as always, click on that link, make a copy, and once it loads, make sure you go here to the Move button and make sure you save this in a chemistry folder so it's easy to find. So I've titled this Google Slides presentation Part 4 of your Unit 6 notes. This is the 4th Google Slides presentation you've gotten on the Unit 6 topics. And this is going to cover a topic called stoichiometry, which includes mole ratios and converting from mass of one thing to mass of the other. On page 2, you've got another table of contents to help you quickly navigate through to find what you need. And on page 3 is where we started working today. So, here we have the recipe for making a s'more. Making 1 s'more requires 2 graham crackers, 4 chocolate pieces, 2 marshmallows, and you will yield, or you will make, 1 s'more. So it's written already on our slide as a balanced chemical equation. 2 graham crackers plus 4 chocolate pieces plus 2 marshmallows yields 1 s'more. I took another stab at it, and you were more than welcome to write this or to not write this onto your slide. I wrote it a bit more like a chemical equation. I have 2Gc plus 4Cp plus 2MM yields 1Gc2, Cp4, and M2. So once again, I have the balanced chemical equation at the top there from the last slide. So now we're noticing that making s'mores is a lot like a chemical reaction. Which of those 5 chemical reactions that we learned about does this represent? The answer is a synthesis reaction. Remember, a synthesis reaction has 2 or more reactants that combine to form one product. So here I've got 3 different reactants, graham crackers, chocolate, and marshmallows, and they yield only one type of product, a completed s'more. Question 2 asks us, how many of each ingredient is needed to make 1 s'more? Well, we need 2 graham crackers will equal 1 s'more made. 4 chocolate pieces will equal 1 s'more made. And 2 marshmallows will be equal to 1 s'more made. We just made 3 equivalency statements. We use the information in the chemical equation to fill out these equivalencies. Notice, whatever number was the coefficient became the amount or the value in that equivalency statement. When I have a balanced reaction, those coefficients make my molar ratio, they make my equivalency statements. Question number 3 asks, if you have 100 graham crackers and unlimited chocolate and marshmallows, how many s'mores could you make? So notice, I really like to color code things. So like I often suggest, I have highlighted my given value and its units in red. So what I have to start with, my given value is 100 graham crackers. So I know that I have 100 graham crackers, and I want to solve for how many s'mores I can make. Well, if I start with graham crackers, then I'm going to want to divide by graham crackers. If I look at my equivalency statements, I have graham crackers to s'mores, chocolate pieces to s'mores, marshmallows to s'mores. I can convert from graham crackers to s'mores. So my top unit is going to be s'mores. Now I want to take my values from my equivalency statements. So 2 graham crackers is equal to 1 s'more. So now I have 100 graham crackers multiplied by 1 s'more, so that gives me 100 graham cracker s'mores. Then I'm going to divide that by 2 graham crackers. So graham cracker is canceled out by graham cracker, and I'm left with 100 s'mores divided by 2. So my final answer is 50 s'mores. Part B says, how many chocolate pieces do you need to make the number of s'mores from part A? So it's a little ambiguous here what our given is. Do we go back to 100 graham crackers? Or do we use the 50 s'mores, which was our answer from A? Now, usually, I would like you to go back to the very original given of 100 graham crackers. But with our given equivalency statements, it's a little bit easier if we start with 50 s'mores. And Part B references the number of s'mores from Part A. So it's okay to use the s'mores from Part A. So my given is 50 s'mores. So if my given unit is s'mores, Without even thinking too much about what my problem is, I know that my bottom unit is going to be s'mores. Now, I do need to look at the question now. I have s'mores and chocolate pieces. So if I look at my equivalency statements, I do have s'mores and chocolate pieces. So on top, the unit I'm solving for is chocolate pieces. Again, I take my values from my equivalency statement. 1 s'more is equal to 4 chocolate pieces. So I have 50 s'mores times 4 chocolate pieces, which gives me 200 s'more chocolate pieces. And then I'm going to divide by what's on the bottom. So 200 s'more chocolate pieces divided by 1 s'more means my s'more units are going to cancel out. And I will be left with 200 chocolate pieces. Part C says, how many marshmallows do you need to make the number of s'mores from part A? Well, once again, I'm going to start with my 50 s'mores from part A as my given. Remember, it doesn't matter what your starting unit is. No matter what it is, I always, always, always will make it my first unit on the bottom. I want to get rid of it. It's trash. I throw it to the floor because apparently we're a bunch of litter bugs. Then I look for my equivalency. I have s'mores and marshmallows. So marshmallows will go on top. I hope you notice I've also gone through color coding this so they match the equivalency that you use. When I look at my equivalency statement, I've got 2 marshmallows and 1 s'more. So a 2 goes with my MM and 1 goes with my s'more. I have 50 s'mores times 2 marshmallows. So that gives me 100 s'more marshmallows. Then I have 100 s'more marshmallows divided by 1 s'more. So my s'mores cancel out. And I am left with 100 marshmallows and a very deep craving for some s'mores. On slide 5, we took that idea and we started to apply it to chemistry and actual chemical equations. So here we've been asked, how many moles of oxygen, O2, are needed to react with 25 moles of hydrogen, H2, to form water, H2O? So the first thing we had to do was balance our chemical equation. We found the answer was 2 moles of H2 plus 1 mole of O2 will yield 2 moles of H2O. So my mole ratio for this question, my given is hydrogen, H2. I'm finding oxygen, so moles of O2. So to fill in this equivalency statement, I just took my coefficients from the problem. There's a 2 in front of my H2. So in my equivalency statement, I put a 2 in front of my moles of H2. There's a 1 in front of my O2 in the chemical equation. So I'm going to put a 1 in front of my moles of O2 in my molar ratio. I have everything I need to solve this problem. So now I'm going to start by filling out my factor label grid. I start with my given. I've been given 25.0 moles of hydrogen. Now remember, it's very important that you tell me not just that it's moles, but moles of what? Because once I start to fill out this factor label grid, I have moles of H2 in my first box. So in my first bottom box, I want to get rid of that. I'm going to have moles of H2. Here, I'm going from moles of H2 to moles of O2. So on the top box, I've got moles of O2. Notice, if I didn't say what these are moles of, this would become very confusing. I wouldn't know where to put the 1. I wouldn't know where to put the 2 from my equivalency statement. I need to make sure that I clearly label not just the unit, but the substance as well. So moles is my unit, H2 or O2 are my substances. Thankfully, I did label them clearly, so I know that a 2 goes on the bottom along with moles of H2, and a 1 is going to go on the top along with moles of O2. So now I have 25.0 moles of H2 times 1 mole O2. So I have 25.0 mole H2 mole O2 divided by 2 moles H2. So my mole of H2 gets canceled because it divides by itself. So I'm left with 25 divided by 2. So my final answer is 12.5 moles of O2. Next, our question asks us, how many moles of H2O will be produced? So I'm going to start by filling out my mole ratio. In my balanced chemical equation, I have 2 moles of H2. In my balanced chemical equation, I have 2 for my coefficient in front of H2. So I have 2 moles of H2 are equal to, and I have a coefficient of 2 in front of my H2O, so 2 moles of H2O. Now notice my ratio here is 2 to 2. So if you want to, you can simplify this as a 1-to-1 ratio. However, when I do the math, I won't be simplifying it, so you can see where these numbers are coming from. I'm going to start this conversion problem once again with the same given, 25.0 moles of H2. Since I'm starting with moles of H2, the very first thing I want to get rid of is moles of H2. So I'm going to put that unit on the bottom. Right here, moles of H2 will convert into moles of H2O. So moles of H2O is what I put on the top. Now I fill in my numbers, 2 with H2 and 2 with H2O. So I have moles of hydrogen divided by moles of hydrogen. Those are going to cancel. So I'm left with 25 times 2 gives me 50, divided by 2 gives me 25. So my final answer is 25 moles of H2O. We finished up on slide 6 of our Google Slides presentation by giving you some time to do some independent practice. I gave you the balanced chemical equation of 1 mole of nitrogen gas plus 3 moles of hydrogen gas will yield 2 moles of ammonia. And you were asked to find the number of moles of nitrogen that would be needed in order to react with 6.3 moles of hydrogen H2. So I highlighted our given in red. We start with 6.30 moles of H2. Since I have started with moles of H2, I want to get rid of moles of H2. I am converting into moles of N2. It's what I've been asked for. You can always convert between 2 different moles in your reaction. And over here in my equivalency statement, I have 1 mole of N2 since my coefficient is a 1. And I have 3 moles of H2 since my coefficient is a 3. So now I'm going to put those into my factor label grid. 1 goes with nitrogen, and 3 goes with my hydrogen. My hydrogen cancels out moles of hydrogen. So I'm left with 6.30 times 1 divided by 3 for a final answer of 2.1 moles of N2. Next, you were asked, how many moles of ammonia will be produced? Now, the mole ratio that's there on your page asks for your number of moles of nitrogen equal to a number of moles of ammonia. So again, I got those coefficients from your balanced equation. 1 mole of N2 is equal to 2 moles of NH3. So since they set us up to use our nitrogen to find our NH3, I took our final answer from part A and used it as our given for part B. Since I started with moles of N2, I want to divide by moles of N2. And moles of N2 can convert into moles of anything else that's in that equation. Here, what I want is moles of NH3. So I fill in the values from the equivalency statement. 1 mole of N2, 2 moles of ammonia. My moles of N2 cancel. And then I have 2.1 times 2 moles of NH3 divided by 1. My final answer is 4.2 moles of ammonia. But that's not the only way that we can solve a problem like this. In part B, it asks you for the mole ratio for moles of N2 to moles of NH3, which you're able to get easily by pulling the coefficients out of the balanced reaction. So I solved part B based on moles of N2 being equal to moles of NH3 because that's how the question was set up to help you answer it. But that's not the only way to solve a problem like this. I don't have to start with my moles of N2 as my given. I can start with my original number of moles given. I was originally given 6.30 moles of hydrogen. I can figure out how many moles of hydrogen equal how many moles of NH3. Anytime you have a balanced reaction, it's giving you the equivalency of all of those different compounds together. 1 mole of N2 is equal to 3 moles of H2, which is equal to 2 moles of NH3. I can mix and match and rearrange that any way I want because those three things are equal to one another, thanks to this balanced equation. So I can take from here that for every 3 moles of H2, I will get 2 moles of NH3. So I can do the same problem in question B, but using my original number of moles of hydrogen H2. This time, since I'm starting with moles of hydrogen, I want to divide by moles of hydrogen. I'm still looking for the same final answer, which is moles of ammonia. So moles of ammonia goes on top. Then I'm just going to take the numbers from my equivalency statement, 2 moles of my ammonia and 3 moles of H2. So my given unit is still being canceled out by that bottom unit since it's now moles of H2. I'm still being left with moles of NH3. So now I plug this into my calculator. 6.3 times 2. And then I'm going to divide the whole thing by 3. And I should get that same answer of 4.2 moles of ammonia. This is the same thing that you could have done on slide 4. In part B and C, it asked how many chocolate pieces do you need to make the number of s'mores from part A? And how many marshmallows do you need to make the number of s'mores from part A? In B and C, we both used 50 s'mores as our given, since that was our answer in part A. But you could slightly more accurately find the answer if you started with your 100 graham crackers and then converted into chocolate pieces or marshmallows. You would have used a slightly different equivalency, but one that would be easy to find. Instead of 4 chocolate pieces is equal to 1 s'more, you'd be using 2 graham crackers are equal to 4 chocolate pieces. Instead of 2 marshmallows are equal to 1 s'more, you'd be using 2 marshmallows are equal to 2 graham crackers. Whichever way you solved it, you would still end up with those same final answers. I'm hopeful that you guys are able to take to mole conversions pretty simply. In my opinion, I think it's a little bit easier than mole and mass conversions. You don't have to solve for the molar mass, you're just copying from your balanced reaction. And I think it's a little bit easier for moles and particles since although Avogadro's number does not change, it is a bit of a pain to type into your calculator. Remember, if you're still feeling like you're having a little bit of trouble with this, please do the optional homework. I would love to go over and show you the solutions if you come into my office hours sessions. Until I see you guys again, stay safe and make good choices.